It's here on.
Hang on. Good morning, good afternoon, and good evening. It's Wednesday. It's another episode of our weekly technical forum, sponsored by Love My Two. Today we have a old friend and a special guest, Jay Botelho from WildPackets. Going to follow up with his previous presentation, this time with a live demo on his product. Interestingly, we don't have any co-hosts other than Jay and I. Tim cannot make it, and for some reason my other panels couldn't make it neither. So this is truly a Lone Ranger and Toto. I
think
being Toto. Tonto. So welcome to the show, Jay. How are you?
How you guys been? How's everybody doing? I appreciate the opportunity again, Denny. It's really nice to come back, and I'm sure it'll be fine, just you and me on the call here.
Okay. I will try to be nice.
Yeah.
Okay, so I'm going to switch to your presentation screen now.
Okay.
And, why don't you kind of give us an overview of what you want to accomplish today?
Yeah, that's good, and that's why I started with some slides. It is really about a demo, but I wanted to start with the slides just to get. It's a real small subset. I want to get everybody back on the same page from where we were a few weeks ago. So, what I really wanted to start with talking about, it's really the whole topic here is about doing wireless LAN analysis, packet-based wireless LAN analysis in this age of AC. It really started with N, but in this age of AC, where there were some really new challenges, and we're addressing those challenges with basically a new packet collection and analysis appliance that we have. But where I wanted to
quickly, Jay, if you don't mind, what is that one thing that makes AC special?
What makes AC special, and like I said, it started with N, but what makes it special is not every device needs to have the same capabilities. And the reason that's a problem is for exactly what people might be seeing on the screen, a picture of my laptop with a bunch of USB dongles off, right? This is the way that people traditionally, well, not even traditionally, still the way people today basically do wireless LAN analysis, right? They have a laptop, they're trying to be portable, and we're using USB devices, which are basically client wireless LAN adapters to want to capture the data. And back to my original premise, the problem being that not all devices need to have the same capability leads to exactly this problem. So what you see on that picture are three USB adapters that are 11N 3-stream. So, but a USB adapter doesn't have to be an N adapter doesn't have to be 3-stream. It could be 1-stream. It can be 2-stream. It can be whatever the capability of that device is. As long as it's still compatible with an access point, it gets Wi-Fi Alliance certified. Everything works fine, right? And that's great when you're trying to deal with connectivity. But when you're trying to deal with packet capture, now that's a problem, because if those devices, I told you they're 3-stream, but if they were 1-stream, they're not going to capture any 2-stream N traffic or any 3-stream N traffic. You won't even see it when you do the capture. Won't even know it's in your network. So as a network analyst, you're blind to anything that device can't pick up. That started with N. It's even worse with AC. Now as we go to AC, because now we're talking about 3-stream and 4-stream access points in Wave 1, and then we're talking about moving to access points that can do multi-user MIMO in Wave 2 with beamforming and sending data to multiple users at the same time, all of these additional complexities, and these USB devices that we used to capture are just not going to catch up. Today we have devices that are up to 2-stream AC in the market that are USB, and I don't think we're going to see anything more than that, because there's no reason for a manufacturer to make a USB wireless LAN adapter that's more than 2-stream. I mean, the whole LAN adapter, from the manufacturer's point of view, isn't for it to be used as a packet capture device. That's just a secondary or tertiary even usage of it. It's really designed to make a device that doesn't have 802.11 to provide it the capability to connect to an 802.11 network. There's no reason for anything that doesn't have 802.11 built into it today to have anything more than a 2-stream adapter attached to it. And odds are most devices today are going to have 802.11 built in. All this talk about Internet of Things, everything else, whole nother topic, but the main point of it here is some sort of connectivity. Typically 802.11 is going to be built into each and every one of them. So
Yeah.
that's that's that problem.
Interesting.
Yeah.
Okay.
So yeah, and I'm not saying this approach that I'm showing on in the picture is dead. There are certainly going to be many applications, especially guys that are consultants, et cetera, that go on site where people still don't want to do this type of mobile analysis, mobile packet capture and analysis for wireless LANs, but we need to be those of us that are doing it need to be smarter or really think carefully about what it is we're doing. If we're going to go into an environment with a two-stream AC adapter to capture packets, we better be sure to have in mind that we're only going to capture two-stream traffic. If there's three-stream and four-stream traffic, we won't see that. We've got to hope that's not what's contributing to our problem. If there's a huge volume of traffic that's three-stream and four-stream, and we don't see that, we may think, "Ooh, not a very busy network," when it could be an extremely busy network, and we just can't see it. So not dead, but people need to think about it. So basically, this slide just reiterates that, gives one example. Whereas today, most access points are at 1.3 gigabits per second, three-stream AC, and the adapter that's often used with OmniPeak today is that little AE6000, which is in the bottom right-hand corner, that little Cisco device, which is only a one-stream AC device, 433 megabits per second. So you're just not going to capture everything. So what we're talking about is today specifically is that box that's in the middle, Omnipliance WiFi. So what Omnipliance Wi-Fi is about, and there's several aspects to this. Number one, Omnipliance Wi-Fi is going to solve it's going to solve the problem that we just talked about by capturing packets from access points in the network rather than from USB devices. So that takes away that problem of that, kind of, I won't call it incompatibility because the devices are compatible, right? But that mismatch of capabilities where, I could have a client device, a USB, that's not as capable, most likely, as my access points. Now I'm going to use one of the same access points that I'm already using in my network as a capture device. So I know it's going to be as capable as my other access points because it's the same model. It's the same thing. So no one's going to be able to connect to an access point in a way that the access point I'm using as a sensor can't see because they're the same device. So it's going to solve that problem. But it solves a second problem as well that we haven't talked about yet, which is the increased difficulty nowadays with being where the problem is. So anybody that's doing wireless LAN analysis today also knows that, unlike wired network analysis where I can capture the packets from my desktop at the first router that I connect to or further up at the switch or maybe even on the backbone, and I'll see the packets from my laptop, right? So I don't necessarily have to be where my laptop is for wired network analysis. But for wireless, if I'm really trying to troubleshoot a wireless problem, I have to be within a few hundred feet of the client or the access point where the problem is to capture the packets. That's the only way to analyze the wireless part of the connection. And today, with so many large enterprises, with so many wireless networks dispersed across campuses, across countries, even across the globe, but still only 2 or 3, network engineers that are responsible for the wireless LAN, they can't be where all these problems are. They have to be able to capture data remotely to be able to be effective. And this appliance allows you to do that as well. The appliance allows you to be remote. So the way this works is, first we're going to put the access points themselves, or certain ones, in promiscuous mode or in sniffer mode. Most of the manufacturers call it sniffer mode, and that's something that's done outside of our products. It's done through the UI for the controller. So the user goes into the UI just as they would today to set up that access point, to put it on certain channels and stuff, but instead they're going to choose the sniffer mode rather than AP mode. They're going to put it into the channel they want, and the last thing they're going to do is give it an IP address once they put it in sniffer mode. And that IP address is going to be the IP address of the Omnipliance Wi-Fi. So as soon as they hit save or apply or whatever it is for that particular UI, it's going to change that access point into a sniffer, and then every packet that AP sniffs is going to be redirected to the IP address that was given, and that's going to be the IP address for Omnipliance Wi-Fi. So then we're going to use OmniPeak just as we would use it today, but now we're going to use it as a console. So instead of using it as the direct device that's being used to capture the packets, we're going to use it as a console to connect to the appliance that's going to capture the packets from the access points. And then once we configure our capture, the data is just going to begin flowing from one or more of the access points. It doesn't matter how many. This is going to flow up into the appliance. The appliance is going to analyze all of that data, and then we're going to see the results of that analysis in OmniPeak. So it again solves those two problems. It allows people to remotely get data from anywhere. These access points could be anywhere in the network. They could be across the campus. They could be across the country. As long as they are network accessible to the appliance, they can send the packets to the appliance. And as long as OmniPeak is network accessible to the appliance, it can see the results of all that analysis. The appliance is designed, we'll see it here, so it's a 1U appliance. It's the last of the slides before we demo. It's a 1U appliance that it supports multi-gigabit capture rates. That's one of the other unique things about it. Today, when one tries to use a laptop with USB devices connected to it, of course, there's a limitation to the laptop. You can have a pretty powerful laptop, and that will help. But you're also then constrained by the bus that the USB devices are connected to, and all that kind of stuff, right? With Omnipliance Wi-Fi, it has a 4-port 1 gig card in it, so it's got 4 1 gig ports on the back, so we can capture up to 4 gig of wired packets, because remember the packets that are coming from the access point to the appliance are now being tunneled on the wired network, so we can get up to 4 gigabits per second of tunneled traffic back into the Omnipliance Wi-Fi. It can do real-time analysis, but even better yet, really designed for doing forensics analysis. And what we mean by that is it's really designed to capture all of the packets as they come in and store them in files so that the user can go back in time when a problem is reported and go see exactly what was going on in that slice of time. Without having to then go back and start a capture and figure out where it is. All of the packets are there to go and analyze. It's got 8 terabytes of storage on it for recording those packets, so that would be good depending on the amount of traffic you're pumping at the box, and thinking about that aggregate traffic 24 hours a day. It's good for hours or days of wireless LAN traffic. And then again, captures from the existing or dedicated APs. And what I mean, there's a distinction drawn there, and I want to draw that out. So users may take one of two different approaches. Users may want to use the appliance in a very proactive way, meaning that they would dedicate certain access points to always be sensors. So instead of having to go into your network and always switching the mode of access points, purchasing a few extra access points and putting them in sniffer mode permanently allows you to 24/7 send packets from those sniffers, those sniffer access points, into the appliance and always have all the data you need. Other users may want to still follow the approach today they follow with a portable solution, which is it's more reactive. There's a problem, I go to the area where the problem is, I start a capture with my laptop. Same approach can still be used with the appliance. It's just that what you would do now is instead of walking out there with your laptop, you would go to the appliance, go to the access points go to an access point, or maybe several that are in the area where the problem is, not one that's involved in the problem, but one that's near the problem, put it in sniffer mode, and let it sniff what's going on between the clients and the access point where you think the problem is. So you can do proactive, you can do reactive. The only difference between the two is, of course, maybe spending a little extra money on access points if you're going to dedicate them as sniffers. But still, better than a sensor-based solution, because a sensor-based solution, if you decide you don't need that sensor anymore, it's a boat anchor. There's nothing more you can do with that sensor. If you buy extra APs as sniffers and somewhere along the way decide you don't want them dedicated as sniffers, well, they're still perfectly good access points. Just put them somewhere else in your network, and you haven't lost any money at all with the access points. The analysis gets performed locally on the Omnipliance Wi-Fi, so the packets are only sent over the wired network from the access point to the appliance. They're not sent across the network all the way back to OmniPeak. And we're out of the gate with our Omnipliance Wi-Fi testing with 2 industry-leading wireless equipment vendors, Aruba and Cisco, with access points from them, with more to follow as we go on. So the way this looks an OmniPeak, excuse me. Well, yeah, we can see OmniPeak. Okay, so now I'm in OmniPeak. So for those of you that are, you may or may not be familiar with OmniPeak, but if you're not, you know, the primary use of OmniPeak in wireless today, as I said, is to use it as a local portable wireless LAN analysis device. If you're not that other product, freeware product that shall not be named, or Wireshark, similar kind of approach where you're going to capture packets with it. But what we're going to do now is turn the tables with OmniPeak, and instead of connecting local USB adapters to it, we're going to use it as a console. So that's this first screen that we're looking at. It's actually used as a console. It's connecting to something we call an engine, or our Omnipliance WiFi, which actually runs what we call our engine software. So I'm connected remotely to an appliance, not an identical appliance to the one I showed you the picture of. This is actually just a test box that's running the software. So I talked to you about it having 8 terabytes of disk space, and I don't even know if it's large enough to read, but if you could, in the top panel, you'd see at the bottom capture storage, and it says only 7.3 gigs available. So that's not one of these 8 terabyte machines. It's only an 8 gig machine. But that doesn't really matter for the purposes of the demo. But I'm connected remotely to that appliance. That happens to be somewhere else in the building I'm in, but again, could be anywhere on the network. And I'm able to go start multiple captures on that box. And the way we do that, I brought up another screen that shows 4 what we call access point adapters. So that represents each of the 4 ports that are on that box. So each can handle up to a gig's worth of traffic. And it's E2, 3, 5, it doesn't really matter, but that's what it is. And you do see that each one has a unique address. There's 172.20.42.42, 43.42, 44.42, 45.42. That's just the way we did them. As long as they just need independent IP addresses, so then we are going to direct the traffic from APs at one of these adapters. And we can direct traffic from multiple APs into a single adapter as long as we don't exceed the 1 gigabit per second limit for that port. Mm-hmm. So up to the 4 gigabits per second. So that's where the data comes in. So
Jay, how do you handle the synchronization issue? Because I understand that those 4 channels are tunneled in.
Right.
Network, right?
The way we're handling that today is the way that would come into play is in kind of the timestamping of the packets. And today we timestamp the packets when they come into the appliance, rather than taking the timestamps from the access points themselves to alleviate that problem, because the access points could kind of be all over the map. We are investigating in future versions providing an option for people to either timestamp the packets when they come into the appliance, or use the timestamp that comes with them from the APs. If they've done a good job of synchronizing their APs, if the APs are all on an NTP server or something, for example, then perhaps they can take the timestamps from the access points.
So once the packets coming in from the 4 channels that are timestamped, then the appliance is not as critical then, right? Because you can actually have a software-based solution, could you not? Because then
well, you could, but the thing about the appliance is you could have a software-based solution, but you would need a relatively powerful box like this appliance. I mean, the appliance is a 4-processor box, right? It's got the 4-port 1 gig card in it, so you would need an equivalent kind of appliance. But sure, I mean, really for WildPackets in the industry, really our core competency is in the software side. So it's really the software on the box that's making the difference. But yeah, today we're selling it as an appliance. But
okay, got it.
So and then this is probably small, if at all. But you can see there are 4 captures running on the appliance, and some are what we call forensics, and some are what we call monitoring. So we can go into the monitoring capture, and when we go look at the monitoring capture, we can see. So we have an access point or more, one or more access points feeding this particular adapter, and we see all the things that we would typically see in Omnipeak. We see our network dashboard, where we see the utilization over time. We see below that our wireless signal strength for the channels that we're capturing on. So you can see we have data coming in from channel 149 and 153, 157, 157N and 161A. So we're probably doing an 80 megahertz scan, an 80 megahertz channel around 157. So we're seeing data on both sides of that. You can see our signal strength. All these bars are green, which indicates, except for a few of them here, but generally the signal strength is very good. We can see our current activity, and down toward the bottom we can see our top protocols. So sorry, I had to switch that over, and now we can see our top talkers by physical address. So when the box first comes up, it wants to show these addresses as IP addresses, and if we're not doing decryption, we don't see them that way. So, but now we can see who our top users are, and what our top protocols are, our top protocols being encrypted data, etc. So all of this is being done remotely. It's like I'm there, but I'm not. And other views that are interesting from the wireless perspective is our wireless LAN view, where again I'm remotely capturing. I don't need to be anywhere near this problem is, yet I can see all of this information about my network. I can see all of the different networks that are out there. Yosemite is a network, WildBright AC, Treat VoIP, Ruckus Wireless. These are all different networks that the access points that are currently capturing packets are able to see. And like you might expect in a typical corporate environment, not all these are WildPackets. Yosemite is not WildPackets. Unify APAC, not WildPackets. Treat VoIP, not WildPackets. PMB HD, that's one of our neighbors. Several of these are our neighbors. JMH Guest, that's our neighbor downstairs. So we can see the data from everything that's going on. So we get a complete view of the wireless LAN, all remotely, all from capturing packets on an access point. So this is when we're doing just a live capture, doing real-time analysis. So we can do it in real time. But you might have noticed when we were back in that engines page, we also had some that we called forensics captures. So in a forensics capture, we can go to our forensics tab. This is a little bit different now, where in the forensics, we're basically just going to write the data to disk. So we have a more limited set of real-time data to look at, but we're able to write these packets to disk at very, very high rates. And then the way we do analysis when it's post-incident is we may pick a slice in time, like this funny little slice in time here where all of a sudden our throughput dropped for a little bit. Maybe we want to go investigate that. So we just highlight that slice in time, using the mouse, and then go do what we call a forensic search. And then within that forensic search, we can decide if we want to tweak the time range a little, apply some filters if we want to, any one of the filters we already have on the box, turn on or off certain types of analysis options, and maybe to make it go a little bit faster. And then we just click Start. And it'll take a little bit, but what it's going to go do is start a forensic search. It's going to go and retrieve those packets from the disk, put them in a different buffer so that we can go and analyze that data. So now, when you see on that left-hand side, now we have some more analysis options available to us. We have our packets view, we have our statistics view, so we can go analyze this data in more detail. We can go into our packets view and see exactly what's been going on in that data. And as you can see, in that packets view, a lot of our encrypted data has been captured at 1.3 gigabits per second because we're using a 3-stream AC client to generate a lot of this encrypted data. We can see all of our management packets, everything about this network we can see here. So the whole appliance Wi-Fi, again, is to be able to do this remotely and do it at very high speeds. So also, unlike Omnipeak, where you might go in and you're going to capture from basically from some USB devices on your device. Now we can get data from multiple locations and bring it in at the same time. So it's a very powerful appliance in that regard, and it will do a lot more than a typical copy of Omnipeak would do, based on the software and based on the hardware that it's running on.
Mm-hmm. What I mean, I'm sure the customers that you're targeting are just like any other customer. They're mission critical applications, typically enterprise customers who needs their network to do their kind of day-to-day functions. So it's very important that they have it up and running at all time. Um, but from a network analysis standpoint, what are the problems that are unique to a Wi-Fi network as opposed to just a wired network?
Well, I think part of what's still unique for wireless is wireless is still one of those technologies where uh, looking at packets is still very important. On wired networks, I think looking at packets has become a little less important just because things are so stable, and diving down into the protocols, and that's not typically where your problem is anymore on a wired network. And it still will help you answer some problems, but on a wireless network, it's still imperative to be able to look at the packets and look at the protocol exchange. A lot of times when there's a problem, the problem is really down at that packet level. Maybe, as an example, maybe somebody's trying to connect to a network, they're trying to authenticate, and we know that it takes a four packet exchange, ePOL exchange, for the key to be able to get exchanged in a public shared key or pre-shared key. And if we don't see all four of those packets, we know that's the problem. We need to look into the level of packets to see things like signal strength. I mean, are some of those packets, are they coming in at a lower signal strength? Are there other issues in there? Diving into the protocol is still extremely important in wireless.
Yeah, I mean that's so when you I mean, like you were showing the screen before where you see your neighbor's traffic. That's not a feature. They're sharing I mean, in the equivalent of a wire world, they're sharing your wire, right?
It's
So
absolutely true. Right, right. Like so all of this was being done on the same channel, right? So
yeah, so your problem gets much closer to the physical.
absolutely, absolutely. It's still, it's like, there's been lots of blogs, several blogs about this in the last, 3 to 6 months, guys talking about this, and what every one of the guys who are doing wireless will tell you is, you need to have in your toolbox, absolutely for wireless, protocol analysis, which is what OmniPeak does. I'm not saying it has to be OmniPeak, but we'd like for it to be OmniPeak, but have to have protocol analysis, have to have spectrum analysis, and really need, at times, some level of site survey as well, especially if you're planning, new network services. But having those two tools, especially spectrum analysis and protocol analysis, is still critical. We run into this still, all the time. Even all of the wireless LAN manufacturers themselves, are doing this type of analysis that we just showed on a routine basis, because they're often having to defend themselves and solve, getting complaints from a customer that, hey, those new access points you sold me aren't working correctly, or this or that, and they're the ones that need to go in and do this kind of analysis and say, well, it might not just be our access points. For example, maybe your test network is this Ruckus Wireless and it's on channel 157, but your neighbor downstairs, PMBHD, is also on channel 157. So that's not something we can solve from an access point standpoint. That's something you have to solve from a configuration standpoint. You have to run software like this and figure out what channels your neighbors are on and get off those channels. So it's still, yeah, it's still a much deeper level of analysis than is basically.
So that's a good place to be, especially in terms of formulating a partnership with company like Cisco and so forth, where I mean, some of these issues are really outside the realm, right? But yet it's what's blocking from them from closing a deal. Kind of their best friend, right? Jay, you're dropping out. Maybe maybe you can close the other. I wonder if it's because you have some bandwidth issue on your end. You might want to shutting down the other session. Can you hear me at all?
I am here for.
I'm just saying that you have two computers running. You might want to shut down one now if you don't use that screen sharing one. It might help.
Um, it's my doors.
Well, it might be Jay. I'm gonna. Looks like I wonder if I don't think it's my problem. Oh, you're back. Jay, are you there? Okay. Well, in any case, maybe I should just close the show. I think you did. You did. If I understand it right, I think you did everything that you wanted to do today. Gave a great presentation about your product and also a demo. So with that, I'm going to close the show. Thank you for coming. Thank you, Jay. I'll call you in a minute to just to close the loop. With that, I'll see you. The next show will be in 2015. Have a great holiday. Bye bye.